Up until this video, we've shown that whenever you want to differentiate x to the power of n here, you simply move this n down here, and then this n itself gets minus by 1. We've shown that this here is true when n equals one of these. So now we're going to consider a case when x is to the power of a fraction. So one of these. In the past, I've always asked you to accept that whenever you want to differentiate something like this, you simply move this down here. So in this case, if you want to differentiate this, in the past I would ask you just to take my word for it, just move this down here, and then just take the whatever here, take away 1. I've always asked you to accept this. So in this video, we're going to prove why you're able to do this. Okay, so let's start out with this. We want to consider the case when n is to the power of any fraction, let's say 3/7. So we would write to the power of any fraction in this form here. By us writing in this form where m and n are integers, where m and n are integers. So by us writing it like this, we will cover all the possible scenarios of x to the power of a fraction. So if you have x to the power of, let's say, 5/11, so in this case the 5 is the m, and then the 11 here is the n. So by us writing it in this form here, we will cover all the possible power of a fraction. Okay, so bear in mind that by us writing in this form here, we will actually cover the square root, or the cube root, or taking the fourth root and so on. Because if you make m to be 1, so x to the power of 1, and then n to be, let's say, 2 here, then this here covers the case of square root. Okay, or if you make m to be 1. So if you make m to be 1 and then n to be the number 3, then this here will cover the case of the cube root, and so on. Okay, so by writing like this, we will cover all the roots as well. Okay, so to start out, we'll start out with our equation here. We're going to try and differentiate this here. Remember, we are trying to show that when you differentiate this, you simply move this down here, and then minus this thing here by 1. We are trying to show that this move is possible. So when we come to differentiate this, we cannot use that move. We cannot use this move because we're trying to show that this move here is possible. So when we come to differentiate this, we cannot make that move because we're trying to show that this move is allowed. So when we come to differentiate it, we cannot make that move. Okay, so start out with this here. And then the next step is to exponentiate both sides. So power it to the n to both sides, if that makes sense. So for example, in the past I've shown you that if you have an equation blah 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 equals another blah 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 over here, you can add equally, you can take away equally, you can times equally, you can divide equally, but now you can actually square equally as well, or if you know that one thing equals another thing, you can cube equally as well, or you can power it to the power of 4 to both sides equally as well. You are allowed to do that. So in this case, you know that you can power it to the 5. So that means so we can dot here, and then we can actually say we can power it to the n. So my point is that when you have an equation, my point is that when you have an equation where you know that one thing here is equal to another thing, well, you can power it to the n to both sides. So we started out with this. Remember, we started out with this. We want to be able to differentiate this without making that move, because without making this move here. Okay, we want to be able to differentiate this without making that move. So what we do here, the trick here is to power both sides by n. So when you power this by n and then power this by n, that will give you this. Okay, so So our aim here, the important part is, our aim here is to try to differentiate this without making this move. Okay, because we are trying to show that this move is possible, that this move is legitimate. So we cannot make this move here. Well, anyway, so this thing equals this thing. So we're going to power it to the n to both sides. So that will then give us this equals this. Now remember from our indices, if you have this here, then this becomes x to the power of a times b. So now it's simply a matter of this times this. So really you've got m over n times n. So this gets multiplied to the top. The two n's cancel out, leaving you with the m. So this would then, well, this side now, well, we started out with this, power it to the n to both sides, and then that will give us this. Okay, so in the next video we will continue from here. So we're going to try and differentiate this. Yeah, but we will then use implicit differentiation to work this out. Well, I will show you in the next video. Okay, in the next video we will carry on from here.